What if a massive solar flare slammed into Earth tomorrow? Strong enough to knock out the power grid for months? A solar flare is a sudden explosion of radiation from the sun's surface. The dangerous ones come paired with a coronal mass ejection, a billion-ton cloud of magnetized plasma hurled outward at millions of miles per hour, aimed straight at us. This actually happened before. In 1859, the Carrington event slammed into Earth's magnetic field so hard that telegraph wires sparked, shocked operators, and caught fire, the only global infrastructure humanity had at the time. Today, a Carrington-level strike would be catastrophic. Induced currents would overload high-voltage transformers, the backbone of the power grid. Large transformers take months to manufacture and ship. Tens of millions of people could lose power for a very long time. Above us, satellites would take a direct hit. GPS accuracy would degrade or fail entirely, disrupting navigation, banking timestamps, and precision agriculture. Some satellites could be knocked offline permanently by the radiation surge. Radio communication would collapse. High-frequency radio used by aviation, shipping, and emergency services would black out for hours in a moderate storm or days across an extreme one. There's an upside, at least visually. The same charged particles that threaten our grid would light up the sky. During a Carrington-class event, auroras have been seen as far south as the Caribbean and Hawaii. On the ground, daily life would grind to a halt in strange ways. Airlines would reroute or ground polar flights to avoid radiation exposure and lost radio contact. Banks and stock exchanges that depend on GPS timestamps for transaction records could be forced to pause trading entirely. Refrigeration, water treatment, and fuel pumps all run on grid power. In a prolonged outage, grocery stores would run out of stock within days, and hospitals would be forced onto backup generators with limited fuel reserves. Economists estimate the real-world price tag at $1 to $2 trillion in the first year alone, with a full recovery taking anywhere from 4 to 10 years, largely driven by the sheer time it takes to replace destroyed transformers. How much warning would we actually get? A flare's initial radiation reaches Earth in about 8 minutes. The slower coronal mass ejection typically takes 15 to 18 hours. But the most severe storms can arrive in as little as 15 minutes. We're not defenseless. NOAA Space Weather Prediction Center and the DSCOVR satellite watch the sun around the clock, giving grid operators a critical window to power down vulnerable transformers before the wave hits. Could this really happen? In July 2012, a Carrington-strength eruption blasted through Earth's exact orbital position, missing us by only 9 days. Scientists estimate roughly a 1 in 8 chance of a similar event within the next decade. A single storm from 93 million miles away could end up being the most disruptive event of the century. And we won't know exactly when, only that the odds are not in our favor.